Hello everyone, welcome to this lecture on the present worth method. Here in this, today we will take up the case where we have unequal lives of the different alternatives. In the previous lecture on the same topic, that is on the present worth method, we already did calculations for comparing the different alternatives in the case where we have the equal lives. So that we have already seen in the previous lecture on the same present worth analysis. So we have taken up a case where we have an alternative where the economic life of the two are same. As in this case, we have studied where we are comparing alternative or asset A with alternative or asset B. That is the case of equal lives. Today in this, we will take up a case where the economic alternatives, they have the different lives. Say for example, the comparison of asset C with A or asset C with B. So today we will discuss how the present worth method is applied when we are having a case where the economic life of the alternatives, they are different. Some examples. This is the example which we solved in the previous lecture. Now here the difference is that in this case we have taken the economic life of the three robots to be different. Earlier in the previous analysis, the economic life is same for all the three robots and we did calculations to select the best robo based on the present worth method. In this case, if the lives are different, how we are going to compare the three robots? That is the key question which need to be answered. This is because of the fact that either choice will not provide the same or the desired level of output, as each alternative is having a different time frame or the life cycle. So let's see how we can compare the alternatives when we have this type of case. The possibility is, there are two or three possibilities, but here we will be discussing just one possibility. So what is that possibility? The possibility is, if we see the economic life of robo A, it is of 2 years. So what we can do, we can purchase this robo 4 times, so that the study period will be equal to that of 8 years life, which is the LCM of 2, 4 and 8. So we can purchase this robo 4 times. Of course, this one will be salvaged when the economic life of 2 years is over, and again it will be repurchased at the same point of time, again use it for 2 years and salvaged it at the end of 4 years. So this cycle we can do for, or this cycle we can repeat 4 times. Similarly, we can go for the purchase of robo B 2 times, as the economic life is given as 4. So purchasing it 2 times will make the economic life equal to 8 years, and no need of purchasing the robo C again and again, because the economic life is already given as 8 years. So this is what we mean by the repeatability assumption. It means that the cash flow will repeat again and again if we are making the purchases over and above the economic life of that particular alternative. Say in this, if we are studying the cash flows for robo A up to 2 years, the same will be repeated when we are purchasing it again at the end of second year and using it for another 2 years. Similarly, at the end of 4 years, we are again purchasing it, the same cash flow will be repeated. So this is what we mean by the repeatability assumption in a cash flow diagram, and this is extremely useful when we study the problems pertaining to the different lives of the alternatives. Let us see with the help of a cash flow what do we mean by the repeatability assumption. So this is the cash flow for Robo A for the first 4 years. So if I repeat this cash flow, if I purchase this Robo 2 times, the same cash flow will be repeated. Now for the second flat cash flow, since for the first one it starts from 0, so the second cash flow will start from 4, then 5, 6 and 7, but rather fourth is nothing but this is the initial point if we are just focusing on the second cash flow. That is 4 corresponds to 0, 5 corresponds to 1, 6 corresponds to 2, so on and so forth. So if we just add these two cash flow diagrams, what we will be having a cash flow with an economic life of 8 years. Of course, the first cost will be appearing 2 times. One is at the beginning of year 1 or at time t equal to 0, and another one will be appearing at the time at t equal to 4 when we are repurchasing it because of the repeatability assumption. Expected incomes, operating and maintenance cost will continue till 8 years, and of course salvage value will be appearing 2 times because one Robo will be salvaged at the end of 4 year, and since purchasing it second time, so it will be salvaged second time at the end of 8th year. So this is what we mean by the repeatability assumption. Now let us extend this repeatability assumption to solve a very simple problem using the present worth method. This is the problem from Briggs unsolved. So 3 plans are there, plans A, B and C. The life cycle of each plan is of course different. For plan A it is 6, for plan B it is 3, and for plan C it is 4. The first cost is given and the annual costs are given. So using the present worth method, we have to compute what is the present worth of each of the plan, or rather which plan is best suited. So in this, if we just take up the LCM of 6, 3 and 4, it will be 12 years. That means plan A is to be executed 2 times, plan B is to be executed 4 times, and plan C is to be executed 3 times. So let's see how the cash flow will look like and what is the solution to this problem. So let's see the solution of the problem where the different alternatives have different economic or useful life. So in this problem we have 3 plans, plans A, B and C, and the life cycle for plan A is 6, for plan B it is 3, and for plan C it is 4. So if I just find out the LCM of 6, 3 and 4, this comes out to be 12. So which means that we have to draw the cash flow for each plan up to 12 years. Let's start with plan A. The cash flow is as follows. Initially I am drawing it just for 6 years, then I'll extend it to 12. 1, 2, 3, 4, 5 and 6. Fine. The first cost is given as $2,000. Okay, first cost $2,000, and then the annual costs, they are given as $3,200. Okay, so this will be a bit larger in magnitude. So the value of each of these transactions is $3200. Fine. So if I just find out what is, forget about the 12 years of economic life, what I am interested in, I will be solving it in 2 ways. So if I just find out the present worth of this cash flow. So P1 is already given as $2,000, and for P2, if I see here, these are the annuities, the first transaction taking place at the end of year 1 and continuing till the end of the economic life. So directly I can use the relationship between P and A. So the relationship is like this. So if I write down the numerical values, so A is given as 3200, 1 point, interest rate is given as 7%, so it is to the power 6 minus 1 over 0.07, 1.07 to the power 6. So if I find out the value of this comes out to be $15,259.92. Fine. So this is the value of P2. Now just for 6 years, if I am interested in finding out the present worth, of course not up to 12 but rather 1 to 6 for option A, this will be equal to 2000 plus 15259.92. both these arrows, they are in the same direction, so I'm adding it up. So if I find out, this comes out to be 17252.92, of course, dollars. So this, what I have calculated, I have just calculated the value or the present worth of plan A for 6 years. So this will be the present value of the plan if we are just studying, if the studying period or the economic life is 6 years. So just keep this thing in a box, we will be using it later. Now let's see if I just extend this cash flow for 12 years. So in one case I am drawing it for complete 12 years, 0, 1, 2, 3. This will be 11 and then this is 12. So one transaction of the first cost 2000 and another first cost will come here 2000 at the end of year 6 and a uniform series. So I'm not taking the magnitude into consideration, so this is why these arrows are a bit smaller, although ideally the magnitude should be taken into account and these arrows must be of greater length as compared to 2000. Okay, so this is the annuities, $3200. So this is the complete cash flow for the 12 years. Here what we are doing, we are taking the advantage of the repeatability assumption, and at this point of time we are purchasing the plan A or going for plan A once again, that is investing rupees 2000, dollar 2000 as the first cost, and these are the annual costs which continues till the end of 12 years. So if I just find out the present worth of plan A by this, when I'm drawing the complete cash flow diagram, so here 12 is not that much large, so I can draw the cash flow for 12 years, but if it is a case of 50 years or 60 years, then sometimes it will be difficult to draw the cash flow. So we'll see how we'll take up that case also. So if I just write the expression for the present worth of plan A. So 2000, this is already at the present point of time, so directly 2000 plus we have annuities starting at the end of year 1 and continuing till the end of year 12. So if I just directly write down the relation, so it will be 3200 1.07 to the power 12 minus 1 upon 0.07 1.07 to the power 12 bracket close. So what I have done here, I have converted all these annuities into present point of time, and we have another transaction at the end of year 6, so treating this to be the future worth. So straight away writing the formula with the numerical values, it will be 2000 divided by 1.07 to the power 6. And if I compute this value, this comes out to be 28,749.280. So this is the present worth of plan A. So I have drawn the cash flow up to 12 years, and with that I have computed this. Now if I look at this cash flow and I take into consideration this one, that is when I have calculated the present worth up to year 6, this cash flow can be, we can redraw it 0, 6, 12. So I am repeating this cash flow again starting from the end of year 7 and continuing till the end of year 12. So this is the present worth which is already calculated, and this comes out to be 17252.92. So this is this one. Now since we are using the repeatability assumption, so when we are repeating this cash flow starting at the end of year 6 and continuing till 12, we will be having another transaction, the same transaction, but this same transaction will be now at the end of year 6, and the amount of this transaction is same what we are having here, that is $1217252.92. So instead of drawing it this for complete 12 years, I can just reduce it somewhat. My efforts will be reduced. Like if we just if we use the concept of repeatability. So this thing we are getting at time t equal to 0, and since because of the repeatability assumption, this value will repeat again at the end of 6 years when we are calculating the equivalent worth of the cash flow, which starts at 6 or at the end of year 7 and continues till 12. So if we just draw for the remainings, this 6 will be 0, 1, 2, 3, 4, 5, 6. So this is the second cycle which we take into account. So it simply means that whatever equivalent worth we are having here, the same will be repeated at the end of year 6. And if I just compute the present worth by this, it comes out to be same. Let's see. So this is already at present point of time 17252.92, and if I just convert this at the present point of time, it will be 17252.92 divided by 1.07 to the power 6. If you compute this, this comes out to be again same what we are getting here, that is 28,749.280. So instead of drawing the diagram for the full 12 years, I have drawn it using the repeatability assumption, and you see the present worth in both the cases is coming out to be same. Fine, so this is the present worth of plan A when we are extending the useful life of this plan up to 12 years. Now let's see for plan B. So for plan B, if we just see for plan B, the economic life is given as 0, 1, 2, 3 years. The first cost is given as $8,000 and the annual cost is given as $700. So let us compute the present worth of this. So present worth of this will be 8,000 plus, okay, let me write down the formula first, okay, 1 plus I to the power n minus 1 upon I 1 plus I to the power n. So if I just fill up the numerical values, this will be 8,000 plus A is given as 700, 1 plus I 1.07 to the power 3 minus 1 upon 0.07, 1.07 to the power 3. If I just compute the numerical value of this, it comes out to be 9837.021 dollars. Now using the repeatability assumption, so this, the LCM is 12, so this is to be repeated 0, 3, 6, 9 and 12. So 1 we have already calculated, this is 9837.021, and the same transaction will appear here at the end of year 3rd, again at the end of year 6th, and again at the end of year 9, not at 12, at the end of year 9, because whatever is happening here, the present worth will be calculated at this point of time. So if I just find out the present worth, now we have to treat each individual transaction as the future value and find its corresponding present worth. So if I write the expression, so present worth for plan B, this is already at present, so I'll write down this as it is. Now this is the future worth and we have to compute the present worth. So 9837.021 over f upon 1 plus I to the power n. So this will be 3. Again in the next one, 9837.021 over 1.07 to the power 6, and the last one as 1837.021 and 1.07 to the power 9. So this will be the present worth of plan B when we are using the repeatability assumption and extending the life of this up to 12 years. So if I just compute this, this comes out to be $29772. This is the future, this is the present worth of plan B. On similar lines, if I draw it for plan C, so plan C, the economic life is given as 4 years. So let me draw it for 4 years first. The first cost is given as $10,000, and then the annual costs, they are given as $500. So if I compute the present worth of this, it will be 10,000 plus 500, 1.07 to the power 4 minus 1 upon 0.07, 1.07 to the power 4. If I compute this, this comes out to be $11,693.605. Fine. Now again, with the help of repeatability assumption, I can draw this as 0, 4, 8, and 12. So this is what we have evaluated: 11,693.605. The same transaction will be there at the end of year 4, at the end of year 8. So if I just find out the present worth of plan C, this will be equal to 11,693.605 plus treating this as future worth and finding out its equivalent at the present point of time. So F, treating this as F, 11,693 divided by 1.07 to the power 4. Then we have another term for the transaction that is there at the end of 8th year. So it will be 11,693.605 divided by 1.07 to the power 8. And if I compute the numerical value of this, this comes out to be $2,742.0.384. So this is how we use the repeatability assumption to find out the present worth of the alternatives where there is a difference in the economic life or the useful life of each alternative. So if I just summarize, okay, let me use a different colored pen. If I just summarize, so for present worth for plan A, this comes out to be, for A comes out to be $28749. I'm not writing the after decimal values. Present worth for plan B, this comes out to be 29772, of course, dollars. And the present worth for plan C, this comes out to be 27420. If one has to select that which plan is one should opt for, then obviously these are the expenditures. So the one with the minimum expenditure should be opted. So if we see here, the minimum expenditure is when one is going for opting the plan C, because in this plan their minimum expenditure is there. So this is the plan which one should select as it is having the minimum expenditure. So this is how we solve the problem where the assets or the different alternatives, they are having different economic or useful life. So this is all about the present worth method by taking into consideration the different economic lives of the alternatives. Hope you have gained some insight of how to deal the problems whenever we are having the different economic life of the alternatives. Again, the same may be applied if we are using, instead of present worth, if we are using the annual worth method or the future worth method. Hope you have enjoyed this lecture and gained some insight of solving the cash flow problems based on unequal lives of the asset. Thank you very much. Have a nice day.